Hi, welcome to Math 320. My name is Julian Banks. I'm going to be your instructor for the course, and this is the first of our lecture videos. So this is going to be for week one, and we're going to be working straight out of the workbook. So follow along. Feel free to pause, rewind if you need to cover anything, or take it at your own pace, basically. So first thing, right, you're going to want to put your information into the workbook just so in case, if you ever lose it, people can contact you or, at least have an idea of where to return it. So, first thing, student name. Well, okay, name's Julian. Let's go for that. Course section, this is Math 320. All right. You know our meeting time and our location. You know my email, my office. Instructor name, well, it's a bit awkward. It's me, so Julian. But you get the idea. You just go ahead and fill out your information. I would recommend putting your email on here as well and your phone number just in case anybody finds it so they can return it back to you. So let's jump in. So section 6.1. This is the first section we're going to be covering, and it's going to be over the topic of factoring. Factoring is huge. Literally everything we're going to be doing in this course is going to come back to factoring. So really get the basics down, really understand these fundamentals because they're never going to go away. And if you can really get this topic down and you get comfortable with it, I really think the rest of the course is a breeze. So, tune in, lock in here, and we're just going to go over a little bit of review, and then we're going to get into more of what Math 320 is all about. So, number one says find the greatest common factor of 24 and 42. So first thing is break this down, right? You're looking for the greatest common factor. Take it one piece at a time. First, find the factors. So we need to find the factors of 24 and the factors of 42. What I like to do is I like to organize them by what they call factor pairs. And they're the pairs of factors that multiply to give you the number. So what numbers multiply to give me 24? But I don't want to start listing out numbers all willy-nilly because then it's easy to lose track. I want to have a method. I want to be able to go in order so I don't miss anything. So I start off with the first two factors that we should all know, which will always be 1 and the number itself, in this case 24. Because what is 1 times 24? 24, right? Big surprise. So those are our first factor pairs. Then we keep going on the list. We say, okay, what about 2? Well, 24 is even, so 2 has to go into it. And then, okay, well, if we double this guy, what's half of 24? 12. And sure enough, 2 times 12, 24. Good. Then what about 3? Well, yeah, 3 works. 3 times 8. What about 4? Yep, same deal. It works as well. 4 times 6. There's little patterns you can notice that can save you some time. If you notice, there's this cool little pattern where if you go from 2 to 4, you know that that's times 2. So guess how you can always find this other factor? Do the opposite. Divided by 2. What's 12 divided by 2? 6. So that's a nice way of finding new factors. Because usually dividing by 2 or so isn't that bad. But that's going to help out more in the bigger numbers. But for now, just list the factor pairs. Go, from 1 to the ending number and then work your way down. And then when the numbers meet in the middle, right, there's nothing between 4 and 6 that are factors of 24, you're done. Let's do the same thing with 42. Right, first factors are always 1 in the number. Then 42 is even, so 2 goes into it. And then, double this guy, so what's half? Divided by 2, what's 42 divided by 2? What's half of 42? Well, that's 21. Right, and just using this technique from over here. Now what next? What about 3? Does 3 go into 42? Fun little trick. If you want to know if something is divisible by 3, add the digits. And if that's divisible by 3, then the whole thing is divisible by 3. So 42 is just a 4 and a 2. Well, that's 6. Can 3 go into 6? Certainly can, so guess what? I know 3 can go into 42. So then, okay, what are my factors? 3 and 14. What about 4? Well, no, because if I double 2, I get 4, but I can't cut 21 in half because that won't give me a whole number. So 4 doesn't work, 5 doesn't work. What about 6? Oh, well, yeah, if I double 3, I get 6, and if I cut 14 in half, I get 7. right? This is the same thing I talked about, times 2 divided by 2. It's a nice little pattern to make your life a little easier. And then 6 and 7 meet in the middle. There's nothing in between, so we know we found all the factors of 42. Now, the next step is we found the factors. We need to find the common factors. So which factors do these guys have in common? Well, they both have 1. They both have 2. They both have 3. This has a 4, but this doesn't. 6, 6, and then that's pretty much it. So our common factors, right, are what? 1, 2, 3, 6. Well, we just don't want the common factors. We want the greatest common factor. So which one of these guys is the greatest? 6, and so that is our greatest common factor. And you're going to repeat the same technique over here for 36 and 42, right? So same deal, you would write all your factors. 36, we have 1 in 36, 2 in 18, 3 and 12, 4 and 9, and of course 6 times 6 is 36. And what about 42? 1 in 42, 2 and 21. No, we just did these, right? We can just borrow our numbers from over here. 3 and 14. Work smarter, not harder, right? I'm all about that. And then again, we find all the common ones and we try to find the largest. And looking at these numbers, we can see that it's going to be 6 again as our greatest common factor. So there we go. Moving on, they want you to factor these two expressions. Factoring isn't complicated. Factoring basically means what? When you factor something, you're just finding what it has in common. That's it. So what does 9y and 18 have in common? What's the largest amount that they have in common? So here's my rule. First, do the numbers. Second, deal with the variables. So what's the greatest common factor that I have between 9 and 18? Well, we know 9 fits into 18, so 9 is our greatest common factor. What about variables? Well, this one has a y, but this one doesn't. So do they have that in common if only one of them has it? No. So guess what? This number 9 by itself is our greatest common factor. So you factor only what they have in common. If they don't have it in common, you don't factor it. Simple as that. What about here? Same deal. Do the numbers first. 18 and 6. What's the common factor? 6. Well, this has an x and this doesn't. Do they have that in common then? No. So we're done. Our answer is 6. So we just keep working our way down like that. This is another example here. We have 15a squared and 12n, and they want us to find the greatest common factor. Well, same as before, we work on the numbers first, right? 15 and 12, what's the greatest common factor there? Oh, that's 3, right? 15 is 3 times 5, 12 is 3 times 4. So 3 goes into both of them. And then what about the variables? Well, this has an a squared, and this has an n. Well, last time I checked, a is not the same thing as n, so are those in common? No. So guess what? 3 by itself, that's our answer. What about over here? We have 9w cubed and 8w squared. Well, the numbers are 9 and 8. Well, the factors of 9 are just 1 and 9, 3 and 3. The factors of 8 are 1 and 8, 2 and 4. You see, the only common factor here is really 1, but everything has 1 in common, so that's not really that important, right? We know that the factor is 1, so okay, that's the most they have in common in terms of the numbers. What about the variables? Well, this is w cubed and this is w squared. Well, it looks like those are two different things, but you have to remember what w cubed means. Whenever you have an exponent, it's telling you how many times to multiply. That's why when you see x squared, it's telling you to multiply x twice, x times x. If you have x cubed, we want you to multiply x 3 times. X times x times x. So on and so forth. X to the 4th, multiply x 4 times. So when I see, right, and that's just the basic idea. Now let's apply it. When I see w cubed, I know that means multiply w 3 times. W times w times w. That's w cubed. And when I see w squared, I know that's w times w. So now when I ask you, what do they have in common, you should say, oh, they have 2 w's in common. And what's w times w? W squared. So guess what these guys have in common? W squared. Because w cubed has a w squared hiding inside of it. And this guy has a w squared, so at most, what do they have in common? 2 of those w's, which give us w squared. And that's our answer, because remember our number was just 1, so we could write 1 w squared, but how many w squareds do you have here? Just 1, so any need to write the 1? Not really. We know there's just one of them, because that's the only thing we have. So what about the next part? Find the greatest common factor of these two expressions. Same deal. Numbers first, and then you do the variables 1 by 1 by 1. 20 and 24, I'll let you do the work on the side on your own here, but the greatest common factor is 4. Well, here we have 7 v's and 6 v's. Well, at most they have 6 v's in common. Here we have 3 u's and 8 u's. Well, at most they have 3 u's in common. And here we have 5 w's, but this has no w's, so they don't have it in common. So this is our answer. Right, we have the 4 that's in common between 24 and 20. We have the 6 v's. Sorry, I kind of covered that one up. And then we have the 3 u's. And so this right here is our greatest common factor. So that's that. And let's move on to the next page here. Find the greatest common factor. Same deal. Numbers first, and then go the variables one at a time, taking the most that they have in common. Right? So you get the idea. Hope that was helpful. Continue on for the next video, and we'll just work through all these problems and make sure everybody's ready to go for quiz 1 coming up in 2 weeks. So welcome to Math 320. Thanks for joining, and I will talk to you later. Bye.